Hi, this is my presentation on stoichiometry, which I talked about in class today. So I'm introducing chapter 12, so we're going to talk about stoichiometry and what it is. So stoichiometry is basically studying the relative amounts of reactants and products from any chemical reaction. Um, it is based upon the law of conservation of mass, and so um, basically for a chemical reaction, we're going to utilize it to calculate chemical quantities. Okay, so remember, the reason why it's based upon the law of conservation of mass is because the atoms of the reactants and the atoms of the products are identical, they just rearrange themselves. So stoichiometry requires a balanced chemical equation. And so you can think of the balanced chemical equation as like our recipe to make whatever product that happens to be. Um, Now, the numbers that we use to balance equations we call coefficients, but these numbers mean something, especially in stoichiometry. So let's talk a little bit about how we can interpret these numbers. So what you see on this slide is a word equation involving iron and oxygen basically creating rust or iron 3 oxide. So when we balance this equation, we require 4 atoms of Fe, 3 molecules of O2 to make 2 formula units of Fe2O3. And if you multiply the amount of atoms on both sides, reactants and products, the iron atoms both on both sides both equal 4, and we have 6 oxygen atoms on both sides as well. But what do these numbers mean as far as stoichiometry goes? In terms of interpreting the numbers in this equation in terms of coefficients, the numbers directly refer to the number of representative particles. So in other words, I can say 4 atoms of iron combined with 3 molecules of oxygen to produce 2 formula units of Fe2O3. Another way we can directly interpret this equation is in terms of moles. So I can say 4 moles of Fe and 3 moles of O2, if they're combined together, will make 2 moles of Fe2O3. So you can kind of think of the atoms and moles as our ingredients. Now, the one thing we cannot interpret directly is grams. So I can't say, for instance, 4 grams plus 3 grams makes 2 grams. That doesn't make any sense, right? But what we can do is we can multiply the molar mass of each substance by the balancing coefficient, and the mass will then therefore add up, proving that the law of conservation of mass is conserved. So 4 times the molar mass of Fe is 223.4, 3 times the molar mass of O2 is 96, and then 2 times the molar mass of Fe2O3 is 319.4. Notice that if you add up both reactants, that equals the mass of the products. And so we cannot directly interpret grams with these balanced coefficients. We can use moles, but not grams. So we learned in our last chapter, that we can convert from moles to grams, though. So we're going to take advantage of that as we begin to solve problems. In terms of mole ratios are very important for us. So if we go back and look at our previous slide, we talked about how this is a recipe, right? So one way of interpreting this is saying for every 4 moles of Fe that react, I need 3 moles of O2. And I can also say for every 3 moles of O2 that reacts, assuming I have enough iron, I should get 2 moles of Fe2O3. Stoichiometry maintains the proportionality of these constants. For instance, let's say instead I have 12 moles of Fe. I would expect to, if I had 12 moles of Fe, that would require 4 moles of O2. Or if I had 40 moles of Fe and plenty of O2, I would expect to make 20 moles of Fe2O3. So that's kind of what stoichiometry is. We're kind of scaling things relative to the balance coefficients. And so we can make mole ratios between any two substances in a balanced chemical equation. I can do it between reactants. I can do it between a reactant and a product, or products. Okay. From now on, the A I'm going to be referring to from here and later on in chapter 12 is going to refer to the given compound. That'll make more sense in section 12.2. And then B will refer to the compound we're trying to solve for. And so that ratio will always be moles of B over moles of A. And we'll talk more about that in our next lecture.